x is the dependent goes in the y. And what we're looking for is a pattern in the data that represents a linear trend. So there are 4 things we look for whenever we're looking at a scatter plot and looking at a pattern of it. So the first thing we're going to look at is the shape. So is there a linear trend to it, a curve, a linear trend? So that just means, is there a curvature pattern? Is there a nonlinear trend, or is there no relationship? So if there's a nonlinear trend, there could be like a cubic trend or a quadratic trend. And if there's no relationship, it's basically just a scatter of data points that has no obvious pattern we can see. So the second thing we look at is the direction. So is the pattern have a positive trend or a negative trend? So does that mean if we draw a line to the data set, does it have a positive or negative slope? Third, what is the strength of the trend? So are all of the data points pretty close to the line, or does the line that we draw not fit the data set well, and the strength of the trend is weak? And the last thing we're going to talk about is the unusual points we see, and as we discussed in earlier chapters, we call these outliers. So let's look at a couple of examples to illustrate this. So first one we're going to look at is the bottom left one. So here we have the x and the y axis in a scatter plot. So obviously there is no trend going on there. It's just a random scatter of points. So we can say there's no relationship between the independent and the dependent variable. So, but on the plot on the right, you can see that all those points that I drew fit pretty close to that line. So therefore, we can say there's a strong negative linear relationship, and then we have an outlier just up here. So does everyone understand why it's a negative linear relationship? Because of the negative slope of the line. Okay, everything so far is pretty self-explanatory. So we could also have a curvilinear or nonlinear trend. So in this case, the data points kind of exhibit a quadratic trend, so it kind of looks like a parabola, if you remember from college algebra or high school algebra, whatever. So that's what we call curvilinear, or you could just say quadratic in this case, since it does have a quadratic trend. And then finally, in the bottom right, we have a weak positive linear relationship. So there is a linear relationship somewhat, so these data points do have a kind of a linear pattern to them, but the line that we fit to them is not very good because those points do not lie close to the line like they do above. So therefore, we say there's a weak positive linear relationship. Everyone following that up to there? Okay. Okay, so the next thing we're going to do is actually create a scatter plot and identify a few things. And then after we do that, we'll get out of here. So let's try an example. So a professor wishes to see if there is a relationship between the number of absences and the final grades of 7 randomly selected students in her statistics class. So what is the independent variable? So what is being manipulated or changing in this case? And that is the number of absences. So it's changing per student. So each individual student will have a different number of absences, or they won't. And what are we measuring? What is the dependent variable in this case? We're measuring their final grades. So that means on the x-axis, we're going to plot the number of absences. The y-axis, we're going to plot their corresponding final grade. So now we have some data below. So here we have the number of absences and their corresponding final grades. So here you have 6 and 82, so that's this person right here. 2 and 86, this person right here. 15 and 43, you just suck. 9 and 74, and then so on and so forth. So if I want to draw a line to kind of represent this data, I can draw a line in here, because if I do that, then most of these points are going to lie close to this line. So what can we conclude about the scatter plot? We have a fairly strong negative linear relationship between the two variables, the independent being the number of absences and the y variable being the final grades. So, and does everyone understand why it is a negative linear relationship? Because as the number of absences goes up, your final grade goes down. So there's a negative slope to the line. So that is, I guess we can talk a little bit more since we have 4 minutes. So if a linear relationship is possible, we can use something known as the correlation coefficient to determine the strength of the linear relationship between the two. So for a population, we denote the population correlation coefficient to be this thing. It looks like a P, but it's kind of tilted, and we call it a rho. So it's the Greek letter rho. This represents the correlation computed by using all possible pairs of data values taken from a certain population. And then for a sample, we denote the sample correlation coefficient. So in this case, we're looking at the sample linear correlation coefficient with an R, and this represents the correlation computed from sample data and measures the strength and direction of a linear relationship between two quantitative variables. So in this course, we learn how to calculate the Pearson product moment correlation coefficient. So we're just going to calculate this R. And what we want is, so the range of linear correlation coefficient, so it goes from -1 to 1. And what we want is the following. So what does the correlation coefficient tell us? So here we have the correlation coefficient range, so from -1 to 1. So if the correlation coefficient is close to -1, that means there is a strong negative linear relationship between the two variables. If it is close to 0, that means there's no relationship, so it's basically just a scatter of dots. And then if we have a correlation coefficient close to 1, that means there is a strong positive linear relationship. So that means the closer to 0 we get, the weaker the linear relationship is. Oops, almost fell. So how do we calculate this linear correlation coefficient? So here it is at the bottom. You don't really need to know this formula because your calculator will do it whenever we run a test. So next time we'll talk about how we're going to do that test and how you can also do it by hand using a table that you have on your tables packet. So if you weren't here at the beginning of class online, people online, I did open up all of your previous homework assignments. You have the opportunity to improve your grades for your homework assignment if you choose to do so, and they will be due the day before the final exam. So that is all I have. If you have any questions, just let me know.